Hey everyone! With ancient marvels standing strong for millennia while modern structures seem to falter after just a couple of centuries, many are beginning to wonder, what makes stone buildings so enduring? Welcome back to QuestifyX, and today we're diving into the secrets behind the longevity of ancient stone architecture versus modern construction. If you're new here, don't forget to hit subscribe and turn on the notification bell so you never miss our latest videos. Let's dive in. Have you ever noticed that the stone structures of ancient civilizations seem almost immortal? Whether it's majestic temples, pyramids, or towering monuments, these edifices have withstood the test of time for thousands of years. In stark contrast, many modern buildings constructed from brick, concrete, and steel often have a lifespan of only 100 to 200 years before they require major renovations. Consider this. In the West Bank, in the city of Ariha, there's a massive cylindrical stone structure believed to be one of the oldest skyscrapers in history, constructed around 11,000 years ago. Then, think of Malta's Tarxian temples, built some 5,000 years ago, or Egypt's iconic monuments, the Pyramid of Djoser, about 4,700 years old, Karnak Temple, around 4,000 years old, Hatshepsut's Mortuary Temple, 3,500 years old, and Luxor Temple, approximately 3,400 years old. These are not just relics, they are testaments to the enduring power of stone. What is it about stone that grants it such incredible durability? Stone is a natural material formed over millions of years from a blend of minerals, dust, and silicates that are compressed and fused together. This natural process endows stone with exceptional strength and the ability to bear tremendous weight without cracking or collapsing. Moreover, many types of stone, like granite, quartz, and certain limestones, are inherently resistant to the harsh effects of weather, moisture, and even biological decay. Let's compare. Modern building materials like cast iron boast compressive strengths ranging anywhere from 220 to 2,500 megapascals, while the limestone used in many ancient structures typically handles between 14 and 255 megapascals. While cast iron might outperform limestone in pure compressive strength, the key advantage of stone lies in its chemical stability. Stone remains largely unaffected by humidity, oxygen, or microbial activity, factors that often degrade metals and even concrete. In contrast, modern concrete is susceptible to moisture-induced cracking and carbonation, and bricks can deteriorate when exposed to the elements. Beyond material properties, the way ancient structures were designed plays a crucial role. Ancient architects carefully selected building sites with stable, strong soil, like the Giza Plateau, which could support the enormous weight of stone monuments. In modern construction, the ease and speed of using materials such as concrete, reinforced steel, and various types of bricks come at a cost. These materials, while economical and convenient, require constant maintenance. For instance, the Leaning Tower of Pisa, a relatively modern structure by ancient standards, suffers from foundation issues partly because the underlying soil wasn't ideal. Without modern restoration efforts, it would have collapsed long ago. Meanwhile, a piece of stone once cut and shaped can retain its form with minimal deterioration for centuries. In summary, while modern construction materials have revolutionized building techniques with cost efficiency and speed, they often fall short of the enduring resilience found in stone. Ancient builders, through both material selection and meticulous engineering, created structures that have withstood the ravages of time. This remarkable longevity is why stone monuments continue to awe us today. That's it for today. If you've made it this far, you're the best. Don't forget to like the video before you leave, and let us know your thoughts or episode suggestions in the comments. See you next time. Goodbye.